Hello there, I'm Marwin Melgar. This is MELAB-5, currently taking the subject of MELAB-II. Today, I will report some safety precaution of heat exchanger and discuss the procedure on testing of the parallel and counterflow heat exchanger. My other teammates will discuss some types of heat exchanger. On my report, I will discuss the procedure on testing of a parallel and counterflow heat exchanger. We can also learn that the precautionary safety measure in operating heat exchanger. Okay? So, stay tuned. Okay. As we can see in the picture, performance tests on parallel flow and counterflow heat exchanger. Okay. First, let us discuss the background of a heat exchanger. Heat exchanger is a device which is used to transfer heat between a known number of fluids, which is either separated by a solid wall or maybe in the direct contact with each other. It has a broad application in different industries including refrigeration and air conditioning, internal combustion engine, power plants, sewage treatment, etc. On the basis of flow arrangement, a heat exchanger is classified into following main categories. Maybe a parallel flow heat exchanger, a counterflow heat exchanger, cross-flow heat exchanger. These types of heat exchanger will discuss my group teammates. Okay? But I will already summarize the background of this. The fluid enters through the same end in a parallel flow heat exchangers and travels adjacent to each other in a parallel manner in the same direction, while the counterflow heat exchanger fluid moves on opposite direction to each other. It is the most efficient among the three exchanger. Take note, the most efficient among the heat exchanger. In the cross heat exchanger, as name suggests, fluid travels cross to each other. The main objective of this experiment of my report is to determine the performance test, and also we can discuss the safety precaution of the while operating the heat exchanger. Okay. The requirement in testing the parallel flow and counterflow is you can use the heat exchanger first and the valve for flow and direction control, either 5 pieces, thermometer, maybe 4 pieces, measuring flask, stop clock. Okay. We know that in procedure in testing the heat exchangers in parallel and counterflow, this is the procedure. Okay, I'll begin. First of all, start the water supply. Keep the flow rate above 2.5 liter per minute. Maybe maximum up to 7 liter per minute. Okay? For hot water and between 3 to 8 liter per minute for cold water. Okay, take note of that. Place the thermometer in the pockets. Switch on the geyser. Note down the readings after the temperature gets steady. Okay, the temperature must steady after the readings will in the thermometer. Now repeat the experiment by changing the water flow rate and open valves. Okay, so you can repeat the experiment by testing another valve, maybe the valve 2 and the valve 3, and close the valve 1 and valve 4. Okay, take note of that. For counterflow arrangement, now wait till a steady state is achieved and note down the readings. Okay, if the temperature is steady at the steady state, you must take note of that. You must wait till the steady state is achieved, so you can take down the readings. Okay, on my conclusion, the process of finding the heat transfer rate, heat transfer coefficient, or LMTD, and effectiveness of heat exchanger for both parallel and counterflow heat exchanger has been discussed. Be sure to keep the steady water flow rate and temperature before noting down the readings to get accurate result. Okay? Take note of that. The temperature before noting down the readings to get accurate result must the temperature get steady or in the steady state. Okay. Are we cleared? Okay, very good. Stay tuned. Now, we discussed the precautionary safety measures in operating heat exchanger. Okay? Before we discuss the safety precaution of heat exchanger, first let us discuss the preventive maintenance of the heat exchanger. What is the importance of this in our safety in the industrial? Okay? Heat exchangers operating in refineries or petrochemical plants must be truly cleaned and inspected throughout their operational lifetime to ensure safe and efficient operation. These routine procedures are necessary because the equipment comes into contact with various feedstocks, processed chemicals, and cooling water that will develop exchanger fuelant over time. Okay, it will clog the tube. This fuelant can adhere to the walls of the equipment's tube and pipes, as well as inside various valves and flanges, thus causing the exchangers to reduce heat transfer. Okay, it will reduce the heat transfer. Over time, this fuelant will be compounded, which dramatically exchange the flow rates of fluid through the exchangers and causes the loss of efficiency, the clog that what I said a while ago, and increase the risk of unsafe operation. Okay, the safety. Moreover, deposit of fouling can cause hot spots and corrosion condition that lead to premature equipment failure. Non-cost effective. To avoid such result, operation must periodically remove the build-up of fuelant and coat the tubes before they reduce the limit operational efficiencies. This procedure must be done carefully to avoid damage to equipment components and, more importantly, to prevent injury to cleaning personnel. Okay? We discussed the conventional cleaning of the heat exchanger, manually cleaning the tube. Now, as you can see in this picture, this is what we call the hands-free automated equipment. The hands-free automated equipment. This service provides can use automated equipment for both on and off-site cleaning to reduce the safety and environmental risk associated with high-pressure cleaning. Okay, the manual I said. Manual cleaning methods dramatically increase the likelihood of high-pressure injuries. Okay, the operator, it will increase the high risk of injuries because it's moving the high-pressure tube. Okay. To avoid that, we can use this hands-free automated equipment. And chemical exposure, particularly for the operator. Okay? Participating personnel become vulnerable to high cuts hazards, operator fatigue due to added discomfort of wearing PPE or the personal protective equipment, and the risk that comes with holding high-pressure handheld equipment for extended periods of time. Okay, so in this picture we can, if we are not using the conventional method of our operator, we can use this hands-free automated equipment. Heat exchanger safety precaution you should know. Heat exchanger is one of the most important equipments for the manufacturing plant. With this equipment, energy transfer can be done on the production process run smoothly. However, besides its important role, heat exchanger operate and maintenance contain potential safety hazard. If such safety hazards are not treated properly, an unexpected event may happen. So, it is very important to know heat exchanger safety precaution in order to be safe during operation and maintenance. What are the heat exchanger safety hazards? There are several potential heat exchanger safety hazards. Perhaps it could come during the design phase, operation, or maintenance. Hazard associated with improper heat exchanger operation can be hazardous materials leaking, cold metal, brittlement, explosion, fire, and uncontrolled reaction. Meanwhile, during its maintenance, heat exchanger can be severe safety hazard like explosion, fire, and hazard material exposure. Okay? Now, we move on to the heat exchanger accident cases. Okay? What is the importance of this? Learning safety from the past accidents is greatly way to prevent the same event happens out our sites. So, it is very important to learn from any accident case you may can get. I have searched several heat exchanger accident. There are several accidents related in our topic. The one is the water cooler heat exchanger in hydrogen facilities recycling in Japan, and it happened in 2014. Another cases is catastrophic heat exchanger failures in Longford gas plant in Australia in 1998. Another one is the heat exchanger ruptures and ammonia release, Goodyear rubber plant at US in 2008. I searched of this because it is very important to acknowledge the injury or failure in the past so that it will never happen again, or we can prevent happen again. Okay, it is in many industrial companies. It is very crucial the record of the accident in their industry. In my experience, when I'm in the Isuzu manufacturing corporation in Laguna, their main goal is zero accident on a year, or it can less. Because what is the main purpose of that? Because if they were able to achieve the zero accident in their companies, the cost will reduce. Okay, so it is very important that this is some heat exchanger safety precaution during design. Make sure you have decided the appropriate design condition for the heat exchanger type, temperature design, pressure design, material compatibility, supports, gas event, drain, and structural design. Inappropriate design will lead to mechanical integrity problems. 2. Pay attention to the gasket material. Material selection and thickness has to be matched to avoid leakage. That is very important. 3. An abnormal temperature and pressure increase may happen. Design the heat exchanger which can withstand in such condition. 4. The heat exchanger shall be designed for the safety maintenance environment. 5. Overpressure can be avoided by installing a safety relief device. 6. A high relative high temperature surface shall be covered by insulation. 7. Consider to install an alarm system. That is very important to know. Number 8. Grounding is very important. Now, let's move on to the heat exchanger safety precaution during operation. The first one is tube plugging due to the buildup of foulants. This can cause pressure build-up inside the heat exchanger. 2. Beware of the tube leakage causing by corrosion. If the fluid in hot and cold side mix, the reaction may occur. A corrosion monitoring, inspection, and leaking detection are very important. 3. If a slurry flow or contaminated liquid flows into the heat exchanger, erosion may happen and can cause leakage too. Install a filter to separate solid material from a liquid flow. 5. Or number 4. Avoid overpressure the heat exchanger. Do not start up and shut down operation smoothly. Follow the SOP, okay, the manual. 5. Keep out of hot surface that may cause the skin burn. And we know that in the heat exchanger there are so many lots contact that can cause our skin burn. So keep in touch of that. The final one is the heat exchanger safety precaution during maintenance. Number 1. Follow LOTO or the lockout tag out procedure when you will maintain the heat exchanger. Make sure all inlet valves are already secured and tagged appropriately. I remember when I'm in Isuzu that before if the machine have a trouble, only the maintenance section can operate that. They have an ID. There is a stop switch that they were attached that on their ID to be able to see the operator that the machine is already in the maintenance or preventive maintenance to secure that the machine will not operate. Okay. Number 2, release the pressure from the heat exchanger. Ensure that the pressure gauge indicates O bar. Number 3, drain out hazardous chemical from the heat exchanger. 4, be careful when selecting chemical cleaning material for tube. Cleaning improper selection will cause corrosion. Number 5, if chemical methods is used for cleaning the tube side, take care not to cause tube defect. Mechanical cleaning can cause injury on people too. Number 6, install new gasket, mainly on the head, carefully to avoid leakage. Improper installation will lead to leakage. Okay, that is very important. Number 7, hydrostatic test. After maintaining job is secured, be careful to do this job safely because a high pressure will be applied. If that's all my report, I hope you learned something. If you are here at the end of my video, I really appreciated that, man. I hope you click the subscribe and comment below, okay? Stay peace, okay?